Here we want to find the integral of arctan of 8z dz. U substitution does not work in here, so what I'm going to do, I'm just going straight forward to integrate by parts. Remember, integration by part is the integral of u dv equal to uv and then minus integral of v du. The first step is to determine what's u and what's dv. Here we only have arctan of 8z, so I'm gonna set that to u. So u equal to arctan of 8z, and the rest is dv, so dv equal to dz. Now notice in here that the derivative of arctan of x going to be 1 over 1 plus and then what's inside squared. Okay, therefore when we take du, going to be 1 over 1 plus and then 8 z squared, and then we take the derivative of the inside, which is 8 dz. This is going to be equal to 8 dz of 1 plus 64 z squared. And v going to be the integral of dv, which is going to be the integral of dz, which equal to z. Now we're gonna substitute these functions back into the substitution by parts. Now we're gonna plug all of these functions back to the integral by parts. So that's going to be equal to u again is arctan of 8z, and then v is z, and then minus the integral of v, which is z, and du here is this whole term. So that's going to be 8 and then 1 plus 64 z squared then dz. Now what I'm gonna do for the next step, I'm gonna move this constant out of the integral. So this is gonna be equal to arctan of 8z multiplied by z, then minus 8 of z over 1 plus 64 z squared dz. Now for the next step, we want to solve this integral. Notice in here when I take the derivative of this term, it's going to be something with z. So let's do that. And I'm gonna bring that to the side. So we have the integral of z and then over 1 plus 64 z squared dz. Now let's set u equal to denominator, that is going to be equal to 1 plus 64 z squared. Do not confuse this u with this u, they are different. If you are being confused, then you can use a different variable for u substitution. You can make it w substitution. So now du going to be equal to 64 and then 2 of z dz. They're going to be equal to 1 to 8 z dz. Now notice we only have z dz, so I'm gonna move this to the other side. So that's gonna be 1 over 1 to 8 of du equal to z dz. And now we are ready to substitute. So this is gonna be equal to the integral of 1 over, and the denominator is gonna be u, and then z dz gonna be equal to 1 over 128 du. And that equal to, I'm gonna bring the constant out of the integral, and we'll left off with the integral of 1 over u du. That equal to 1 over 1 to 8 of the natural log of the absolute value of u. Now let's back substitute the value of u. Here u is 1 plus 64 z squared. So that's going to be 1 over 1 to 8 natural log of 1 plus 64 z squared. Notice this term is always positive. You can plug 0 for z, it's gonna be positive, and also if you plug positive or negative value, it's gonna be all the time positive. So we can remove the absolute value of the natural log. So that's gonna be equal to 1 over 1 to 8 of natural log of 1 plus 64 z squared. Notice this antiderivative is the result of this integral, which is the same as this integral. So I'm gonna put this back in here. So that's going to be equal to arctan of 8z and then minus 8 multiplied by the antiderivative of this. That's gonna be 1 over 1 to 8 of natural log of 1 plus 64z squared, and then we don't forget the c. And that is the antiderivative of the given integral. So again, here what we did, we use integration by parts, and then we have this integral. We want to integrate this, we use u substitution. So for this problem, we use integration by parts, and also we use integration by substitution. Now let's find this integral, which is the integral of x squared e to the minus x dx. Here, u substitution does not apply for this integral, so I'm just going straight ahead and try integration by parts. Remember, integration by part is when we have the integral of u dv equal to uv, then minus integral of v du. The first step is to choose the value of u and dv. Here from ILATE, this is an acronym to help us to choose what's the function for u. Here we have an exponent function, and then we have algebraic function. You can notice the exponent function is number 5 and the algebraic expression is number 3. So the algebraic expression comes before the exponent, and that's why I'm gonna set x squared to u. And then dv, it's what's left from that integral, which is e to the minus x dx. Here we want to find also v and du. So du going to be equal to 2x dx, and v going to be the integral of dv. That's gonna be the integral of e to the minus x dx. Now how we gonna find this integral? Let's try u substitution in here. I'm gonna set u equal to minus x, and then du going to be equal to minus dx. Notice in here we only have dx in this integral, so I'm gonna move the minus sign to the other side. The integral on the top, which is the integral of e to the minus x dx, going to be equal to the integral of e to u, and then dx is minus du. Now I'm gonna pull the minus sign out of the integral, and we have minus the integral of e to the u du, and we already know the antiderivative of that. It's gonna be minus and then e to the u. Now I'm gonna back substitute the value of u, which is minus x, so that's going to be equal to minus e to the minus x. So what we found in here is just v. So now we are ready to move to integration by parts. So that's going to be equal to u, which is x squared, and then v, which is minus e to the minus x, then minus the integral of v, which is again minus e to the minus x, and then du here is going to be equal to 2x dx. For this integral, I'm going to pull the minus sign and the 2 out. So that's going to be equal to minus x squared of e to the minus x, and then plus, since minus with minus is positive, and then 2 of e to the minus x, and then x dx. Now note in here, to solve this integral, I'm gonna also do integration by part a second time. So this integral going to be equal to uv and then minus the integral of v du, and we have to set what's u and v for this integral. U here going to be equal to x, so it's the algebraic expression, and what's left off as just dv, and that's gonna be equal to e to the minus x dx. From u here, du going to be equal to dx, and v going to be the integral of dv, which is the integral of e to the minus x dx. Notice in here that this integral is the same as this integral, so the solution gonna be equal to this. Now we are ready to solve for this integral. It's going to be from here equal to u, which is x, and then v, it's minus e to the minus x, then minus the integral of e to the minus x. And note in here that du is just dx. So that's going to be equal to minus x e to the minus x, then I'm gonna pull the minus sign, that's gonna be positive, of e to the minus x dx. That's going to be equal to minus x e to the minus x, and then this integral again going to be this integral. So that's going to be equal to minus e to the minus x. Note in here we have this common term, so I'm gonna factor it. We have e to the minus x of minus x minus 1. So note in here, what we just found here equal to here. So this is going to be equal to minus x squared e to the minus x, then plus 2 of this whole term in here. E to the minus x of minus x minus 1, and then we don't forget the c. So what we did this problem first, we use integration by parts, and then we wanted to find v, and then we use u substitution to find that. And then after finding this term, we also had to do integration by parts again to solve this integral. So here, what we have is we did integration by part, and then integration by substitution, and then again integration by part.